Now we have our first system and our first attempt to solve by using Gaussian elimination. Now be careful with this Gaussian elimination. The way it is defined in our textbook is our job is to turn augmented matrix our goal is to turn it into row echelon form. And so remember, with row echelon form, we're going to have a diagonal of ones, or leading ones, a lower left triangle of zeros, and I'll just use little stars because it is up to us to figure out what those other numbers will be. So kind of keep that in mind as you're going through this. So I was going to highlight that. If you kind of know what the end goal is, then it helps you make the decisions as what needs to happen in order for this to go. So first thing we will do for ourselves is we are going to write the augmented matrix based on what we see with the first row, second row, and third row. And with our augmented matrix, as we're looking at the first row, I'm looking at the coefficients of the variables, keeping in mind I always have an X column, a Y column, and a Z column, and a constants column. If you'd like, you can switch up the color if you want to remind yourself that you do have the equal sign. That's helpful. So let's look at the first row. We have a 1x, a -2y, a 4z, and a 6 as a constant. Second row, our second equation, we have a 1x, a 1y, a 13z, and a 6 as a constant as well. And third row, we have 2x minus 6y plus 1z and 10 as a constant. So notice with this augmented matrix for our system, we're kind of quite lucky. We do see that we do have a diagonal of ones. And our goal would be to try to make sure, how do we get this to happen? How can we get this lower left triangle of zeros? Well, we can do this using row operations by hand. Usually how this works is you go step by step. So you kind of sweep downwards and have a goal of turning this one into this leading one into a 0. And then after you get that in a new matrix, you turn this leading 2 into a 0 as well. But for purposes of this course, we're going to be very excited to find out that we can use our TI to turn things into row echelon form. So I'm very excited to go over this with you because you're going to find this a lot nicer than having to multiply everything out and go by hand. So let's pull up our TI and show you how this works. You probably guessed we are using matrices. So a good thing to kind of keep in mind before we start is the dimensions of our augmented matrix. So looking at this, we do have 3 rows and 4 columns. So we have a 3x4 matrix. And I'll erase those markings because I don't want you to get confused with negative signs. I don't want to erase the entire matrix. There we go. So our job is we're going to enter this into our TI. So we're going to pull up our TI. And I prefer to use the matrix second X inverse menu to go through this, because really when you use the matrix shortcut menu using the alpha key, it doesn't really have row echelon form involved in it, so you still have to do the math anyways. So we'll go over this. Again, we're going to press second X inverse, and I just keep everything on matrix A, but before I can call the matrix up, I have to edit it and enter in my particular values and entries for my augmented matrix. So if I'm going to do that, I'm going to make sure first I have the correct dimensions. I have a 3x4. So I'm entering a 3, I'm using the arrow key. I can press enter, and right away it gives me everything. Notice it doesn't show me the bar, I just have to understand that we do have the constants column at the very far right. And from here, what I'm looking for is I'm going to enter everything I see from my matrix that I wrote down. So you may have to refer back to it. So I do have a 1, row 1, column 1. I pressed enter, so that took me to row 1, column 2, so that's a -2. Make sure you're entering the negative sign. It then took me to my third column, row 1, so I'm going to enter a 4. A 4, there we go. And then it took me to the constant. That's the fourth column, so it's entering a 6. Now it took me to row 2, column 1, we're entering a number 1. I pressed enter, took me to row 2, column 2, that should be another 1 as well. Press enter, it took me to row 2, column 3, that should be a 13 this time. And then row 2, column 4, that is another 6. Press enter, it's finally taking me to row 3. I should have a 2 in column 1, a -6 in column 2. Press enter, a 1 in, be careful, look what happened, is accidentally 11. Let's be careful with that. A 1 in column 3 and a 10 in column 4. So that should be my matrix. What I'm going to do, just because I'm switching back and forth between screens, I'm going to copy it and just make sure that I wrote everything down correctly. Let's go back really quick. Just so that we could all compare together. Maybe. See if it will let me copy and paste it really quickly. There we go. So I kind of have to shrink it down just a little bit just to see. So I'm very, very big on just really taking the time to compare the matrix that you entered to your actual augmented matrix that you wrote down. So I'm just double checking each row, 1, -2, 4, 6, 1, 1, 13, 6, 2, -6, 1, and 10, and I'm feeling pretty good. Yes, I have everything taken care of. Okay, so now that that is properly entered, we're going to go back to our TI. And I'd like to get out of the matrix edit menu. So I'm going to say second mode to quit. That's going to take me to the home screen. I think we have some previous matrix multiplication there. I'm going to clear it out. Now what I'd like to do is when I go through these, I'm going to call up the matrix math first. So again, we're going to press second matrix or second X inverse. Use the right arrow key to scroll over to math. And we're going to use the down arrow key to find REF. So that's item number A. So if you press enter, REF, which guess what stands for row echelon form, is called up to the screen. And then now you just have to call up the name of the matrix which you want to turn into row echelon form. So in order to do that, one more time, second X inverse, and this time with the names, you'll notice that part, item number A or matrix A, number 1, is a 3x4, and that's the one we were editing. So we'll press enter, it's already highlighted. I'll close the parenthesis because I'm paranoid. And just wait, you're gonna press enter right now. And notice, it is turning your matrix into row echelon form. One slight issue that you may run into is that sometimes you get decimal entries. And it's okay if you want to work with them, but sometimes the answers want exact answers or fraction entries in your matrix. So this is a quick fix. All you have to do is press math and then use the fraction key. So that's item number 1. And now it's saying, do you want me to turn all the entries in this previous answer to fractions? You press enter and check this out. Isn't that pretty? I love this. Now, just a side note, if you have maybe an older operating system like a TI-83 or I think the previous 84 to this, sometimes you don't see your entire matrix in the viewing window. All you have to do is press the right arrow key and you will see the rest of the entries. So just kind of be aware of that. If you know how your calculator works, you're going to be just fine. So let's take this. All of that work we would have done by hand, it was done in a matter of seconds. So happy about this. I'm going to copy this over so that we can continue to work with this. Notice that when we do copy it over, it is in row echelon form. If I can take this, I can't superimpose it, so I will move it a little bit. There we go. I'm going to copy the other one. And make it a little larger for ourselves, just because it'd be nice just to see things a little bit more. So let's just make sure you guys can see what I see. Yes, you can. Okay, so let's kind of keep in mind what we have just done is we have just turned our augmented matrix into row echelon form. And just kind of reminding ourselves what row echelon form is. We do see that diagonal of ones. See if I can draw that in for myself. Make it a little larger. There we go. And then we do see that lower left triangle of zeros. So we have a zeros, 0, 0. And then we do have other numbers we're going to have to deal with. So we do have -3. We do have a 1/2. We do have a 25/8. I'm going to squeeze that in there. Equal sign, 5, 1/4, and a 2. So this is quite nice because if you're in row echelon form, the next idea that you would do for yourself is to use algebra, to use back substitution to solve the system. So let's take a look at that. If we want to now set our, write our new system of equations coming from this matrix. I will have 1x minus 3y plus 1/2 z, be careful with the 2's and the z's, equals 5. I'll have y plus 25/8z equals 1/4. And then what I'm really interested in is I get the third row, z, 1z equals 2. So right away, you see we've got our solution, at least the z part in our solution. And so what back substitution is telling us to do is we're going to go backwards. And then we're just going to take, hey, if z equals +2, that's going to leave us with y plus 25/8 times +2. Equals 1/4. A little bit of fractions coming into us. And if you want to do this, we could do this by hand. That's no problem. I think I'm going to use blue. I still have y. Now 25/8 times 2, I can do a little bit of reducing. 2 goes into 2 once, 2 goes into 8 4 times. So I should have y plus 25/4 equals 1/4. And if I subtract 25/4 from both sides, what I'm ending up getting, I'm going to have to move a little bit to the left, I'm sorry, or to the right, to your right. This is going to be y equals, this is 1/4 minus 25/4, which ends up giving us, you have a nice common denominator already, -24/4, which gives us -6. So we actually have a nice integer number for the y. Now, once we have the y, we can take the top equation. I might have to move over a little bit with you. We could take this top equation, plug in y and z, and we will get x. So I'm going to have to switch back and forth. I am running out of a little room. So I have x minus 3y. I'm going to write it over again. Plus 1/2 z equals 5. There we go. And so I'll plug in my y. So I have x minus 3 times negative 6 plus 1/2 z equals 5. So x plus 18, that's negative 3 times negative 6, plus 1/2. There's a z. Ah, even better. What was it, 1/2 times 2? A little bit excited there. I tried to move forward. Oh my goodness, what is 1/2 times 2? Just a nice integer, it's a 1. So we have x plus 18 plus 1 equals 5. Little nice simplification. We have x plus 19 equals 5. And then what happens is we will subtract 19 from both sides. So that will leave us with x equals 5, take away 19, and we should have a negative 14. So that is our third solution, or our value of our x. So finally, if we want to write our solution, here's our work. It's a little bit moved. I'll go off to the side. Usually you're going to see your solution written as an ordered triple. So the x value comes first, negative 14. The y value comes second, negative 6. And then the z value is positive 2. We have now just solved our system using Gaussian elimination. So you'll kind of notice that the algebra is a little more friendlier, maybe took a little less paper to do so. So it's a very nice technique to have in your tool bag to pull out whenever you can. And it's especially nicer if we have our TI with us. It's a little less work on that case. So practice this, and we're going to move on to the next example. I'll see you then.